When we think about a global extinction, we usually imagine sudden, violent events, a massive asteroid impact or a supervolcano eruption wiping the slate clean. But Earth's actual demise will be much slower. It's going to be a highly systematic dismantling, orchestrated entirely by our own life-giving sun. Right now, our home is a thriving biological engine, a complex, perfectly balanced machine. But our sun is a main sequence star. Its contracting core makes the star denser, hotter, and 1% brighter every 100 million years. The very star we rely on for survival acts as a ticking clock, steadily pushing our planet toward a mathematical expiration date. This map shows how the current continents will drift together over the next 250 million years, closing the Atlantic and Indian Oceans to form a single massive landmass known as Pangea Proxima. Trapping so much landmass together generates extreme inland climates. Most of the Earth's surface will turn into a baking desert, leaving only the coastlines and polar regions capable of supporting complex life. That massive continental gridlock also blocks the global circulation of ocean currents. Water deeper than a few hundred meters will lose its oxygen, suffocating marine ecosystems. But as the continents shift, the sun's steady brightening continues. Its increasing heat starts to aggressively interfere with the delicate chemical balance of the crust. Plate tectonics will redraw the map, but the sun's escalating energy output will dictate the survival of life. Earth naturally regulates its temperature over millions of years through the carbonate-silicate cycle. Rainwater reacts with rock to pull carbon dioxide out of the air, storing it away to keep the planet cool. As solar heat increases, it speeds up those chemical weathering reactions. The planet tries to cool itself down, pulling carbon dioxide out of the atmosphere much faster than volcanic eruptions can replace it. This chart shows exactly where that regulatory system breaks. Within 500 million years, rising temperatures force atmospheric CO2 levels to plummet below 150 parts per million, the absolute minimum threshold for most plant life. Standard C3 plants, which include our trees, grasses, and major staple crops like wheat, will simply starve. They won't be able to process enough carbon to offset the energy they burn to stay alive. A tiny fraction of vegetation, known as C4 plants, use a different enzyme system. Crops like corn can resist the carbon crash down to just 10 parts per million, but even they will eventually wilt under the rising heat. When the plants die, the entire food web collapses. Herbivores run out of fuel, and the carnivores that rely on them quickly follow. 1 billion years from now, the sun will be 10% brighter. The oceans will begin to evaporate at a massive scale, filling the lower atmosphere with thick steam. All that water vapor acts as an insulating blanket, trapping the sun's heat. That heat boils more ocean water, locking Earth into an uncontrollable runaway greenhouse effect. Losing the oceans triggers a mechanical failure deep underground. Without liquid water to lubricate the crust, plate tectonics physically grind to a halt. Earth becomes a stagnant, paralyzed world. The surface turns into a cracked desert, baking underneath a suffocating layer of carbon dioxide and steam. Surface temperatures will skyrocket to 190 degrees Celsius. Even the hardiest salt-loving microbes hidden in underground ice caves will be cooked alive. Our lush blue home becomes a sterile twin of Venus, a dormant rock with 0 remaining biological signatures. The final blow arrives in about 7.6 billion years. The sun exhausts its hydrogen fuel. Its core collapses, causing its outer layers to violently swell. This diagram shows the sun expanding into a red giant. It swells to over 250 times its current radius, entirely engulfing Earth's orbital path. The planet is physically consumed by the stellar plasma. The crust, the mantle, and the core are completely vaporized into space. The solar system ends its life cycle by physically reclaiming the exact matter it used to build our world in the first place. But there is a major caveat to this timeline. It assumes zero human influence, mapping out only the natural evolution of the planet. We have a compulsive habit of manipulating our environment. If our species survives even a fraction of this time frame, we could intervene with advanced terraforming or simply colonize other star systems. Earth is a rock with a strict biological shelf life, but we are conscious stardust, carrying the technological potential to outlive the world that birthed us. Our planet's expiration date is a thermodynamic certainty, but our survival is a choice.